In this video, we're going to talk about the destructor that we need to add to the C string object we just created. So in our previous implementation, we did not account for destruction. This is important because our object contains a heap object, and we should delete it when the object gets destroyed. If we don't, we'll leak memory, and our class would offer an incomplete abstraction. Basically, when you use the class, it allocates memory, but then when the object gets destroyed, we don't delete the memory. And so what that would mean is over time, if you use these objects a lot, we would eventually consume a lot of memory resources. And even though a user of the object wouldn't be able to see that we're not freeing the memory, they would experience a loss of memory. And possibly their program would crash, especially if it's a long-running program. And that would be bad because we've hidden the bug from them in the abstraction. We definitely don't want to do that. We don't want abstractions to create more problems. So just as a reminder, a destructor always begins with the tilde followed by the class name. It takes no arguments. There can only be one in a class. And for C string, we just need it to delete the array that it allocated. That's really all it has to do. So we're going to add a destructor to our C string object. It's going to look like this, right? We have the tilde at the front. We have the name of the object. No arguments being passed. And then inside the body of the destructor, I just put it here on one line because it's so short. We use the delete keyword to ask it to delete the array that we had previously allocated. Okay, so this is short and sweet. We don't need to do anything else. Okay, but this does lead to a slight problem for us. We are writing our destructor using delete, which is what we should do for any array created by new. But in one of the constructors we originally wrote, we actually used malloc. It's not obvious we use malloc, but actually when you call string duplicate, it's calling malloc internally instead of new. And this is a problem because that means some of our constructors use new and some of them use malloc. And when we get to the structure, we'd have to somehow choose the right one. And that sounds pretty complicated and hard. So rather than having to figure out, did we call new or did we call malloc before, let's just rewrite this constructor so that we definitely use new. So what we're going to do instead is figure out how big the literal is by calling string length. This is fine. String length doesn't allocate memory. And then we use new to allocate a new array. And then I use this function called memcopy that's available in C++ that will just copy the contents of the literal into the new array for us. And I make sure and set this size big enough to include the null character to make sure we get that sentinel value copied over. Okay, so now my constructor is using new instead of malloc. And my destructor is using delete. You know, and also note my new is really new for arrays, right? It has this bracket on the end, which means my delete needs to have a bracket inside of it. Okay, so in summary, the key purpose for a destructor is to free memory or release a critical resource that was previously allocated within an object. And so in this case for C string, we're making that character array. And so in the constructor, we allocate it with new. And so we should free it with delete at the end. And this also brought up this interesting problem that if you're not careful, you might have multiple constructors that do things differently. That's a problem. You need to make sure all your constructors are allocating memory in the same way, or you need to add some extra logic into your object to know, was it a malloc or a free, or was it a malloc or a new, so that you then can deallocate in the proper way.